Hello, I'm Olujimi Ajijola, a cardiac electrophysiologist from the University of California, Los Angeles.
And I'm Josh Lampert, an electrophysiology fellow at Mount Sinai Hospital.
We are here today to discuss a recent paper by Dr. Lampert and his group, where they demonstrated resolution of the electrocardiographic U-wave following transcatheter aortic valvular replacement. Dr. Lampert, would you mind starting by telling us the rationale for the study, what you did, and what you found?
Sure. So there was a very interesting paper out of the Mayo group that demonstrated using a convolutional neural network, which is a machine learning type algorithm that makes predictions, especially using imagery such as an EKG. And what they found was they used a technique called saliency mapping, which tells us what feature the algorithm found most important to make its prediction. And that feature that the algorithm found, that the saliency mapping suggested, was the right precordial U-Waves. So U-Waves present in leads V1 to V3. And what we were wondering was, well, if right precordial U-Waves predict aortic stenosis in patients, can we detect differences before and after valve intervention? And more importantly, can a human take what a machine has predicted and identify it themselves?
So what did you find?
So we found in a TAVR population, so we took 50 patients who were undergoing TAVR, and we found that 62% of them had right precordial U-Waves. And then after TAVR, 87% of those patients had diminution or complete resolution of the U-Wave after TAVR. Now, of those patients who demonstrated U-Wave diminution, 3/4 of them demonstrated complete resolution of the U-Wave, and about 1/4 of them had relative diminution of the U-Wave.
What do you think the mechanisms by which the U-wave resolution might occur?
So our thought is that it's most likely related to wall stress, although other mechanisms can certainly be implicated, such as relative autonomic inputs. Before and after TAVR, the diastolic blood pressure decreased, but there were no significant differences in systolic blood pressure or electrolytes. And also because the median time to the ECG was 2 days after TAVR, it's unlikely that there was any significant remodeling, and also by echocardiography, the wall thickness was the same. Likewise, when we looked at a control population of 50 patients who did not have aortic stenosis, only 3 of the patients, or 6% of the population, had right precordial U-Waves, and all 3 of those patients had diastolic dysfunction on their echocardiogram. So currently our thought is it's likely related to wall stress.
Fascinating. What do you think are the future implications of your work?
So I think that we are at an inflection point in where we take machine learning, in that up to this point, machine learning has overall continued to be a black box. And what we're demonstrating is that humans can learn from the machine learning algorithms and be able to directly apply feature importance to real-time clinical evaluation. Moving forward, I think this is can hopefully be a bridge to taking machine learning and starting to apply it directly to patients, both by clinicians in real time, but also to be able to highlight these features and then look to see how outcomes may differ in the future.
Excellent. I would like to congratulate you and your team for this outstanding contribution to the field of cardiac electrophysiology.
Thank you so much, and thank you to JACC for having me, and the amazing people at Mount Sinai that I had the privilege to work with.
Thank you.